Hello, welcome to my channel. In this video, I'll be discussing Newton's law of universal gravitation. Newton's law of universal gravitation states that two bodies in the universe, let's say M1 and M2, attract each other with a force that is directly proportional to the product of their masses, M1 and M2, and inversely proportional to the square of the distance between them. Evaluating this expression further, we can say F is equals to G M1 M2 divided by D squared, where G is a constant known as the gravitational constant. Now recall that this Newton's law of gravitation, universal gravitation, explains to us some of the mechanics that is involved in the gravitational field. You can imagine this is the earth, okay? And this is a fruit on top of a tree on this surface of the earth, okay? This stalk that is open, this stalk that is holding this fruit, if it breaks, what happens to the fruit? The fruit will drop from where it is and come towards the heart. The reason why it comes towards the heart can be explained by the Newton's law of universal gravitation. The reason why it comes towards the heart is because there is a force of attraction between this body of mass m and the heart, which has a mass of me. And this force is equals to the gravitational constant times the product of the mass of the earth and that of the fruit, all divided by the distance between them. And the distance between this face and the heart, let's say its height, is h. And let's say the radius of the heart is re. So the distance between the two of them will be equals to re plus h squared. Okay. G is a constant which is given to be 6.67 times 10 raised to power minus 11. The radius of the heart is 6.38 times 10 raised to power 6 meters. Okay, which can also be expressed as 6.38 times 10 raised to power 6 times 10 raised to power 3 kilometers. Okay, and the mass of the earth is equals to 5.97 times 10 raised to power 24 kilogram. Okay, now if you look at, let's look at the radius of the earth, which is 6.38 times 10 raised to power 6. If the height of the fruit from the surface of the heart is not so significant as to affect this value, we can just express this as F is equals to G times the product of the masses all over RE squared. And that is because this height can actually be negligible except if it's approaching the value of maybe like 2000 kilometer. Okay, so This can be expressed as this. Recall that the weight of a body of mass m, like this one, can be calculated using the value using the formula m times g, where m is the mass of the body and g is the acceleration due to gravity. Note that the weight, which is a force, which is note that the weight of this object is actually equals to the force of attraction between the earth and these fruits. So we can express this as the weight of this fruit is equals to GME, the product of the masses of the fruit and the earth, divided by RE squared. This M will cancel this M. So therefore, we have G is equals to GME divided by RE squared. And if we input this value, let's see what we'll get. G is known to be 6.67 times 10 raised to power minus 11, and mass of the earth is known to be 5.97 times 10 raised to power 20, all over the radius of the earth squared, which is 6.38 times 10 raised to power 6. If you evaluate this using calculator, you will get G is equals to 9.7 meter per second squared. And this is where this constant comes from. Take note from this expression that as this distance increases, so also the acceleration due to gravity increases. Therefore, the weight of an object as we move to higher altitude tends to decrease. What do I mean? Let's imagine this heart and this an object here. Okay? And from the surface of the earth, from the center of the earth to the object, let's say the height is h. Okay? So, from this expression that acceleration due to gravity is equals to g gravitational constant times the mass of the earth divided by the radius of the earth squared, okay, which is the distance between the body and the center of the earth. As this distance increases, let's say the body is now at this level, the distance has increased in this case, and therefore g will decrease. And from the expression, weight is equals to mg. As the acceleration due to gravity decreases, so also the weight decreases. Therefore, the weight of a body tend to decrease at higher altitude. Let us apply the formula that we learned earlier in this calculation. They said we should calculate the gravitational force between the earth and a 70 kg person at sea level. We are given the constant, the mass of the earth and the radius of the earth and the weight of the person. Let's say this is someone standing on surface of the earth with weight 70 kg, okay, and the mass of the earth is this. So from the earlier calculation, from the earlier formula that we derived, we know that force is equals to the constant, gravitational constant, times m1 times m2 all over the square of the distance between them. If this person is on the surface of the earth, we know the distance between this person and the center of the earth is the radius of the earth. Okay? So, therefore, our formula will be G, mass of the earth, times the mass of the person all over RE squared. And this will be equals to the constant, which is 6.67 times 10 raised to power minus 11 multiplied by the mass of the earth, which is 5.98 times 10 raised to power 24, divided by the radius of the earth squared is 6.38 times 10 raised to power 6 squared. Let's see what we get. So this will be equals to 68.59 Newton. And this is our final answer. If you enjoy this video, kindly like and subscribe to my channel. When you click subscription button, an icon will pop up, which is bell icon. Click it so that you'll be alerted anytime I upload new videos. And also don't forget to share. Once again, thank you for watching. Till I see you in my next video. Take care and bye bye.